Welcome to this platform. So in this video, we are going to answer Science Paper 1, that is Physics, of 2025 at GCE. This paper was written on 5th August 2025. Yeah, and I should say it was very simple. Let us look at the questions. So here was the first question, but very important, let us understand the instruction first. So this paper is made up of 3 sections. So section A, which is 20 marks, and in this one you find multiple choice questions. All right. So let us look at the first question in this case. So the first question reads, that is A1. Elena measured the diameter of a test tube and obtained 1.5 multiplied 10 negative 5 millimeter. What is the value obtained in decimal form? What is the value obtained in decimal form? So, to understand the value in decimal form, look at what was the power. So, the power was negative 3. So, in other words, in front, even not going that, you can just try out and look at this. The first one, if you just move, to make this one 1.5, you just move how many steps? Only 1. So, this is not the answer. This one 1, 2, not the answer. This one 1, 2, 3. So this is the answer. 1, 2, 3, 4. This is not the answer. So the answer therefore here is C. So in decimal form, 1.5 to the power 1.5 multiplied 10 to the power negative 1, negative 3 I mean, is C, which is 0.0015. Let us look at the second question. A car traveling at 10 meters per second, so that was the initial velocity, increases the velocity, this is the final, this is the time taken. So a car traveling at 10 meters per second increases the velocity to 30 meters per second in 5 seconds. What is acceleration? Acceleration is equal to final minus initial divide time. The final was 30 minus 10 divide 5. So that is just 20 divide 5. And you know that this is 4 meters per second square. I guess you get a thing. All right, let us look at the third question. The displacement time graph shows the motion of a cyclist. So as you can see, what was the speed of a cyclist at 4 seconds? Now, where is 4 seconds? 4 seconds, you expect it to be right this side. Now, if you understand this is the displacement, and of course, this is time. When you see a graph moving like this, just know that this is the uniform speed. Now, uniform speed, it means at all point, at this point, at this point, at this point, at this point, at that point, speed is just the same. We do not have 4 seconds at any point here where we can visibly see its distance, but one thing you should know is that along this line there is uniform speed. So if you find it at any point, still be the same. So we are going to use this that is given, which is 5 displacement and time 5. So speed is equals to distance over time. So distance is 5 meters, time is 5 seconds. At this point, this gives us 1 meter per second, and therefore the speed is 1 meter per second. I guess you've gotten a thing. Let's proceed to the fourth question. The energy output of a generator depends on its efficiency and the energy input. Which of the set is the correct values, or which of the set value is correct? So what does it mean? Here they just want us to, how do we calculate efficiency if you're given energy input and energy output? And we need to find efficiency in decimal before we multiply with 100. So efficiency is equals to energy output divide energy input. Okay, multiply by 100. But here, not yet 100, but in decimals. So in other words, we need to divide output and input, and we need the one that is going to give us the correct value. Try out this. Now, if you multiply output 25 divide 50, is it going to give you 0.1? No. If you divide, that is output 6 divide 30. Is it going to give you 0.2? Yes. So the correct answer here is 2. So the one that will give us is a correct set is P. So the answer is P. I guess you've got anything. All right, let us go to question 5. A crane lifts 600 kg mass from through a height of 12 meter in 18 seconds. What is the useful power output of a crane? So power is equals to energy, in this case, divide what? Time. So what is the energy that we are finding? Actually is the potential energy, mgh, divide what? Divide time. Now what is the mgh on top? 600 multiplied by 12 multiplied by 10, which is gravity, divide time 18. The top part is going to give us, should be able to give us 72. Let me just try to punch on the calculator. That is 600 multiply 12 multiply 10. You are able to get 72,000. Then divide 18, and this is able to give you 4,000 watts. Confirm the calculations. So the answer therefore is B. That is question 5. The answer is B. 4,000 watts. That is the power. By what process or processes is heat energy transferred from the sun to the surface of the moon? So heat or energy transfer in terms of the sun, the rays are the ones that are transferred, and these they do not need any medium. So it's all by radiation. All right. Then let us look at question 7. What happened to the speed, wavelength, and speed of water? What happened to speed, wavelength, and frequency of water wave when it moves from a deeper end to shallow end? What really happened? So now, one thing that you should know is that when or the speed of a wave depend on depth of water. How deep the water is. The deeper the water, the higher the speed. So when the depth reduces, speed reduces. So you expect what happened to speed, water wave, and frequency of water when it moves from deeper to shallower. So expect the speed to reduce. So in other words, these are not answers, but the one that has speed to reduce, so speed reduces. Then for the wavelength, it also reduces. When speed reduces, also wavelength reduces. Then for frequency is not dependent on the depth of water, but instead it is influenced, or is not influenced by the depth of water, but instead what influences the frequency is the source. I guess you've gotten a thing. So here the speed reduces, wavelength reduces, and frequency remains the same. So the answer is C. Up to question 8, water waves were produced in a ripple tank using a vibrator of frequency 6 Hz. Which of the following values of speed and wave could have the wave, or could the wave have had? So to answer this question very easily, you look at what connects speed, wavelength, and frequency. Is speed is equals to frequency, wavelength. So now here, we want to see how or which set give us the value of 6 as frequency. So in other words, we make frequency the subject. We are going to have frequency is equals to speed over wavelength. So which of the pair? If you were to look at the first one, it will be 2 divide 6. It will not give us 6. The second one, it will be 4 divide 2. Look at the last one. It will be speed 12 centimeter per second divide 2, which is the wavelength, centimeter. This gives us 6 Hz, and therefore the answer is D. That is how we needed to work this one out. Sound waves are being produced by the radio loudspeaker. Sound waves are being produced by the radio loudspeaker, industrial machinery, and children in a playground. The sound wave have the same So the sound wave do not have the same amplitude. Amplitude determines the loudness of the sound. We can't say that the loudness of these sounds were the same. And the pitch is determined by the frequency. We can't say that the pitch was the same. And the wavelength, we can't say the wavelength of the same, because if the higher the pitch, the shorter the wavelength. So now what is the same here is speed, and therefore the answer is C. Up to question 10. The diagram below shows the reflection when light rays strike a rough surface. So as you can see, incident ray, reflected ray, and you have rough surface. Now, when the light rays falls on the rough surface, we have what kind of reflection? It is called diffuse or irregular reflection. So here the answer is B. Okay, let us look at question 11. The diagram below shows a boy standing 3 meters away from the plane mirror. He then moves 1 meter closer to the mirror. So standing 3 meters away from the mirror. Now, one thing you should understand is that characteristics of the image formed. So for question 11, let us answer question 11. So you're saying, the diagram below shows a boy standing 3 meters away from the plane mirror. He then moves 1 meter closer to the mirror, as you can see, the mirror and the boy. Now, one thing you should know here are the characteristics of the image formed in the mirror. One of the characteristics is that the image or the object is always equidistant. I mean, the image is equidistant to, in other words, the distance where the object is and where the image is are the same. So here where the boy is standing 3 meters away from the mirror, even the image is 3 meters away behind. I guess you get that. When he draws closer 1 meter, which means the distance has reduced to 2 meters, and therefore even the image has drawn closer 1 meter. So in other words, here the answer is 2 meters, which is A. Let us proceed and look at question 12. So for question 12, which of the following is a characteristic of the image formed by the plane mirror? Diminished? No. They are same size. Magnified? No. Real? No. It is virtual. So the answer is D. Up to question 13. Which of the following best compares the magnetic property of iron and steel? Now, iron and steel, when you look at magnetism, these are the ones that you study in terms of their properties. And one thing that you should know is that iron makes a soft magnet and of course a strong magnet. But for steel, it makes a hard magnet or permanent magnet, but yet weak. It is easy to magnetize, that is for iron, and easy to demagnetize. Steel, it is difficult to magnetize and difficult to demagnetize. And therefore here we are looking for iron easy to magnetize. So whatever has difficult, no. Difficult, no. Easy to magnetize, yes. Let us look at on the other one. This one does not form a temporal magnet, it forms a permanent magnet. This leaves us with the answer D. So makes a temporal magnet difficult to magnetize. The answer is D. Let us have a look at question 14. The diagram below shows two metal spheres, R and S, touching each other. Placed on insulating stand. A negatively charged polyethylene is held near sphere R to separate the metal spheres. Negatively charged, then insulating stand. What charge will be on the sphere R and S respectively? So here, what do you think is the answer? So this question, I leave it up to you. And when you determine the answer, please, how you answer it, indicate the question number. This is question 14. And also indicate the answer. Let's say the option is A. And explain the reason why the option is A. Or waiting from to hear from you. Okay, so that question is yours. Make sure that you answer it. Question 15. A battery has a charge of 70 coulomb around a circuit at a constant rate in 1 minute. A battery moves a charge of 70 coulomb around a circuit at a constant rate in 1 minute. What is the current flowing through the circuit? So we are finding current. Now we need to look at what do you use to find current when you are given charge. So current when you are given charge is equals to charge is Q divide time in seconds. So now, what is the charge? It is 70 coulomb. Now, we are given a minute. A minute in second is 60 seconds. So use minutes. Use seconds. So divide 60 seconds. And this we are going to have 1.17 current is measured in amps. So that is the answer to this question. All right? So the answer here is D. Let us look at question 16. Two resistors of 12 ohms, 24 ohms are arranged in parallel. A 4 ohm current flow through a 4 amps current flow through a 12 ohms. Two resistors of 12 ohms and 24 ohms are arranged in parallel. A 4 amps current flows through 12 ohms resistor. So in other words, the current that flows only in this one is 4, not in this one, please. So here we do not know current. So we have more like current going this side, we know it, but current flowing through here, we do not know it. But remember, here at the junction, where the current was coming from, it is the current of 4 ohms plus whatever we do not know, which is the current this side. That is the total current that will come out here, or that will be on the ammeter reading. So the question is, what is the reading of the ammeter? So the ammeter measures the total current in the circuit, but how is it going to be, or what will be the total current in the circuit, or the one that will show on the ammeter? What are we going to do? So like I've already said, when current is coming from this side, when current is flowing from this side, at this junction, it split, or there's sharing of current. So in other words, we are going to have current here. We already have 4 ohms. Then this side, there going to be another current that we do not know. So there's one that we need to calculate. Then we add. So 4 amps plus what we do not know. That is what is going to be on the ammeter as the reading. So let us do this. Now, one thing you should know that these are connected in parallel. And what do they have in common? They have equal voltage. So we are going to try and find the voltage here. If you find the voltage here, that is the same voltage here. If we find the voltage here, we can use voltage and resistance to find the current here. Let us go. So let us find the voltage. So resistance is equals to voltage over current. Let us make voltage the subject. So voltage is equals to current multiply resistor. What is the current? 4. What is the resistor? 12. So what is this? 12 multiplied by 4? 48 volts. So the total voltage in the circuit is 48 volts. So the voltage here is 48 volts. Let us find the current at this point. Current is equals to voltage divide resistor. From this, I've just made current the subject. What is the voltage? 48. What is the resistor? 24. This gives us a 2 amps as current. Then we can add it now. We can add plus 2 amps. And therefore, this gives us what? 6 amps. So the answer here is B. I guess you've gotten a thing. All right, let us proceed to question 17. And they say the diagram below shows a coil in a magnetic field. As you can see, permanent magnets. When the coil forms part of a DC motor, we know we have AC and DC motor. What must be connected to J and K? So here, what must be connected? So you're going to connect what we call a split link. Split link is for AC. Question 18, a transformer is needed to convert 240 supply, so this is the primary voltage, into 6 volts. This is the secondary voltage. supply. If there are 1000 turns on the primary coil, so number of turns on the primary, how many turns should there be on a secondary coil? So what do you do? So you're going to use for that is number of turns, or we can say voltage on the primary. So you're going to say voltage on the primary divide number of turns on the primary is equals to voltage on the secondary divide voltage on the secondary. Oh, number of turns on the secondary. This is an ideal transformer. So now let us replace voltage on the primary is 240. Voltage on the secondary is 6 volts. Then what are number of turns on the primary? 1000. Here we do not know. So we cross multiply. We are going to have 240x is equals to 1000 multiplied by 6. Divide 240. So this is number of turns, please. Number of turns on the secondary. Divide 240, divide 240. So 1000 multiplied by 6 is 6000. Divide 240. The answer is 25. So here the answer is A. Then question 19. Radon gas or radon decays to polonium by emission of alpha particle. Pay attention, emission of alpha particle as shown by the following decay equation. This one. What are the values of P and Q? So we are looking at the original values, which is radon. One thing you should know that the general equation when an element decay by emitting alpha, this is the mass number, this is the atomic number. The mass number reduces by 4, the atomic number reduces by 2, okay, to form this daughter. So in other words, this that you have 218, it reduced by 4. So we are looking at 218. Now going back, we add the 4. So 4 plus 218, that is 222. Then 84 plus 2, that is 86. So the answer is D. An industry buys 200 grams of radioactive sample with a half-life of 5 years. How much of the radioactive sample will remain after 20 years? So we are looking at the sample that remains. So what will remain? So now, what do you do? The calculation, use this one. That is equal to half n, where n is the sample that remains. Okay, then n is the initial sample. Then of course n is the number of half lives. Then how do you find number of half-lives? Number of half-life is equals to capital letter T divide half-life. So capital letter T is the time elapsed or time that passed, time elapsed. Then this one is the half-life. So let us calculate. So we want to find what remains. Do we have the initial? Look at the question. The industry buys. So initially it was 200 grams. So that is the initial. Equal to 1 over 2. Now, n, we can find n. N we are saying is period that elapsed. Look at this. Radioactive sample with half-life. So half-life we already know is 5. So our half-life is 5. How many radioactive sample remain after? So the time that elapsed was what? 20. So you're going to say 20 divide 5. And our n is equals to 4. So this is to the power 4. Now 1 over 2 to the power 4, we distribute the power and it's going to have 1 to the power 4, 2 to the power 4, which is just 1 over 16. 2 to the power 4 is 16, I guess. So n over 200 equal to 1 over 16. We cross multiply. We are going to have 16 n is equals to 200. Divide 16, divide 16. So 200 divide 16. 200 divide 16 Here we have 12.5. So the answer is A. That is a sample that remains. I guess you know how to go about this one. All right, this marks the end of section A. We go now into section B. Okay, section B, let us look at the instruction. You answer also all questions, and this section 45 marks. So answer all questions in this section. Write your answer in the space provided. What is question 1? Question 1 is figure B1.1 shows the many part of the measuring instruments found in the laboratory, instrument A and B. So as you can see the instrument, name the instrument A and B. So A is what you call micrometer screw gauge, micrometer screw gauge. Then B is the vernier caliper. Okay? What physical quantity is measured by instrument A and B? Now, listen here. They are not saying what physical quantity is measured by A, you write. By B, you write. No. What instrument, what physical quantity they commonly measure. So, you know that these measure distances, okay, of short distances, and that is length. So, what they measure is length. Which instrument is most suitable to measure the thickness of a razor blade? So here, the one suitable is the micrometer screw gauge. And you need to know that a micrometer screw gauge usually measure the external diameter, but the vernier caliper measures the internal and external. So take note of those and how they work. All right, so that was about question 1. Let us look at B2. Figure B2.1 shows the wooden ladder of length 4.5 inclined at a vertical height of 1.5. A ladder is used to pull 900 Newton suitcase by applying a force of, so we have the force applied and the force that it is overcoming. This that is being pulled is the force the force applied overcome. So we have load and the effort here. And load, we said, is normally the weight of the object. And the force that you apply is effort. Take note of that. Define a simple machine. So a simple machine, you can define it as the device that make work easy. But I like this one. Is the device by means of which the force applied at one point is used to overcome another force at some point in a system. This one gives me everything that I need to know about the topic. It gives me, it helped me understand that force applied is effort, and of course, what the force that effort overcome is load. So this one I go for this one. But anyway, calculate the velocity ratio of a ladder. That is for the second question. Now, when you are given an incline like this, to find the velocity ratio is distance moved by effort divide distance moved by load. So the distance moved by effort always is a slant one. Take note. And that is the 4.5, that is meter, over the distance moved by load is always the vertical one, 1.5 meter. So this one, I think we should be able to find 3. So here the answer is velocity ratio is equals to distance moved by effort, distance moved by load, which is the 4.5 divide 1.5. And this is going to give us a 3. And therefore the answer is 3. Okay? Let us look at the second question. Calculate the work done on packing case against gravity. So work done against gravity, that is the saying, calculate the work done on the packing case against gravity. So work done, we calculate it here. So we are going to use the force applied, not weight. Don't use 900. This is the weight. Use the force applied and the distance it moves. That is work done by that is work done on the parking case against gravity. So work done is equals to force times the distance. What is the force? The force is 450 Newton. Multiply by, what is the distance? 4.5 meter. So distance has to be in meter. So in this case, how do you then find? So we are going to multiply 4.5 multiplied by 4.5 multiplied by 450, and this is going to give us 2025. So this is 2025. That is Joule. Okay, 2025 Joule. And what a coincidence. All right, calculate the efficiency. How do you find the efficiency? So efficiency, if you are given such, efficiency is equals to mechanical advantage over velocity ratio multiplied by 100. All right, we have the velocity ratio, but we do not have mechanical advantage. So let us find mechanical advantage first. Mechanical advantage is load over effort, ratio of load over effort. Now, if I were to go back to the diagram, the load is that is the load 900 and the effort is 450. So let us calculate. So load is 900, then effort is 450. This is just 2. So velocity ratio, mechanical advantage is what? 2. And we can replace now. Efficiency is equals to, that is 2 divide 3 multiplied by 100. And this one you are going to find 67%. Confirm. So efficiency here was 67%. That is how we answer the second question. Let us go to B3. A crane lift block through a vertical height of 24 meter with a force of 500 or 5,000 Newton at a constant speed of 6 meter per second. It takes 4 seconds to reach the top of the building. How much work is done in getting the block to the top of the building? So work done here is equals to, or potential energy is equals to work done. Okay? So work done therefore is going to be, the force that is given and the distance. Okay? What is the force? I've put this because this is a vertical. So 5,000 multiplied by, what is the distance? 24. So 5,000 multiply 24. So 5,000 multiply 24. And this is giving us 120,000. 120,000 Joule. What is the potential energy gained? So I said potential energy is equal to work done. So the work done in lifting this block to the top of the building is equals to its potential energy. You know that potential energy is a stored energy. And therefore here is equals to 120,000 Joule. All right, calculate the power developed by the block. So power is equals to energy over time. So what is the energy? 120,000 Joule. Divide, what is the time? If we were to look at this, we are given 4 seconds. So divide 4. What are we going to have here? If we divide 4, the answer that we are having is 30,000, as 12 into this is 3. Okay, 4 into 12 is 3. So we are having 30,000. What is this? Power. So watt. I guess we are together up to this point. Let us look at question B4. B4.1 shows a graph of solid pure substance changing its state of matter as it is being heated. Now, here we've not been told that this is water. So some of us, we know that water boils at 100, and now when you see this, all what you see is 100 degrees. You don't even look at the numbers. So look at this: temperature in degrees Celsius, and of course time in minutes. What are the questions? What was the boiling point of the substance? So you know that the first part is the melting and the second there is the boiling. So the boiling point was the 40 degree. So 40 degree Celsius. At what temperature will the substance exist as both liquid and gas? So both liquid and gas is the boiling point also. So it is D and E. At this point, that is where it will exist as liquid and gas. Now, one thing you should know that the substance is starting all from the start here. From here, from the beginning here, it is solid form, liquid form, gas form. So between B and C, you find it in solid and liquid. Then here, liquid and gas. So it is at 40 degree Celsius still. State one difference between boiling and evaporation. Boiling takes place throughout the liquid, while evaporation takes place on the surface of the liquid. You can also include boiling involves there are bubbles produced, while in evaporation no bubbles produced. Then you can talk of also it occurs at a certain temperature, that is for boiling, but for evaporation it occurs at any temperature. So be able to suggest also what you think are the answers on this particular part. Question D: what happened to the heat supplied at the point where there is no change in temperature? So the heat supplied is here specifically. What happened here? What happened to the heat produced here? And also here, or supplied there. So the heat is used in breaking of bonds. The heat applied is used in breaking of bonds between particles, and not to raise the temperature. Okay. That is how we answer that question. And let us go to B5. The diagram below shows waves of frequency 40 Hz. So wave of frequency 40 Hz. Define an amplitude. So the amplitude is just maximum displacement. Is the maximum, let me start with, is the maximum displacement of a particle from its resting position. That is what we call an amplitude, and of course it's denoted by A, measured in meter. Calculate the speed of the wave. Now, when you are given this is the wavelength. We've been given that this is a wavelength. Shows a wave with a frequency. So shows a wave with a frequency. So that is the wavelength. So to calculate the speed is equals to, what are we given? The wavelength is 1.5. Then we are given the frequency, which is 40 Hz. So you can calculate the speed, simply saying frequency times the wavelength. So here we are going to have 1.5 multiplied by 40. 1.5 multiplied by 40, it is going to give us, that is 60 meter per second. 1.5 multiply 40. Okay, this is going to give us 60 meter per second. That is how you find it. Find the period of the wave. That is question C. Find the period of the wave. So period of a wave, what are we given? Here on the question we are given frequency. So there's a relationship that is there between period and frequency. So period is equals to 1 over frequency. So you're going to have 1 over 40, and that is going to give us what? 1 divide 40. 1 divide 40 is 0.025 seconds. 0.05 seconds. That is the answer to this question. So we can write here 0.025 seconds. Okay, we go to question 5. Figure B6.1 shows a ray of light in a semicircular glass block. As you can see, this is a glass block. Define the critical angle. What is a critical angle? Critical angle is the angle of what? Angle of incidence. Angle of incidence at which the angle of refraction, or when the angle of refraction is 90 degree. That is what you call a critical angle. So critical angle is just the angle of incidence at which the angle of refraction is 90 degree, or is the angle of incidence when the angle of refraction is 90 degree. Explain why the ray of light entering glass at A is not refracted. So the one that enters at A, like here, is not refracted, but instead it is reflected. So this is what we call internal total what? Refraction. Internal total refraction is reflected within the medium, and that can only be if the angle of incidence is beyond the critical angle. If the angle of incidence is beyond the critical angle, then that is when this happens. So explain why the glass at A is not refracted. So you can say because the angle of incidence is beyond the critical angle. At that point, internal total reflection occurs. Now, here, what could be your answer? Explain why the ray AB is reflected at B and not refracted. AB is reflected and not refracted. This same answer applies here. Okay? Because the angle of incidence is beyond the critical angle. When it is beyond, internal total reflection occurs. Okay. Then D, on the diagram, complete ray CB to show the approximate path it takes as it leaves the glass. So they are saying this CB on the diagram, we approximate how it will come out. So you need to know that it is moving from dense medium to less dense medium. So you expect it to be refracted away from the normal. So it was supposed to come out straight that way, but it's going to be refracted that way. So that is how it will come out. Okay, so that is the answer for that is D. Okay. Then question B7, that is on magnetism. B7.1 shows a soft iron bar magnet. Draw magnetic field lines from the pole of magnet shown in B7.1. So magnetic field lines runs from north to south. They run from north to south. So you put the arrows there. Even you put the arrows here as they are going this side. Then you can put this, put something like this. Okay. Then even here you can put, no, they are not entering. They are going out like this. Okay. So that is how you can present it. You can put more than one. Like this. So as you can see, they are parallel. So here, just make sure that you draw them nicely. They are parallel to each other, and also they run from north to south. So give two characteristics or property of magnetic field lines. So one, they run from north to south. And this is very important property in identifying the poles. So in the case they ask you which one is north, which one is south, if they just give you the magnetic, show you the magnetic field lines, you should be able to identify. So they run from north to south. Then they are parallel to each other, which means they never meet. Okay? So these are the properties. Then B, state two effect of poles of a magnet, state two effect of the poles of a magnet have on the poles of other magnet. State two effect the poles of magnet have on the other poles of magnet. So one, like poles repel, unlike poles attract. What could be the other effect? Okay, what could be the other effect? So that question is yours. Like poles repel, unlike poles attract. Okay, let us go to B8. The diagram shows the cathode ray oscilloscope. It shows the cathode ray oscilloscope. Name the parts labeled A and B. So the part labeled A and B, what are the parts? So for the part labeled A is what we call control grid. What is the part labeled B? The part labeled B is the anode. Anode. Let me just write it properly. Anode. Okay. Then state the function of the part labeled C. So the part labeled C is diffracting electrons up and down. What is the part labeled C? So we are saying diffracting electrons up and down. Now the question to you is, what is the part labeled C? If it is used in diffracting or it functions in diffracting electrons up and down, what is the part labeled C? Then state how electrons are produced in the cathode ray oscilloscope. So they are produced by what we call fermi ionic emission. Okay, fermi ionic emission. This occurs by heating the cathode filament. So by heating a cathode, using a filament. That is how electrons are produced. All right, so this brings us to the end of question. There's another question on question 8. Explain why the tube of a cathode ray is evacuated. Evacuated, which means why it has no air particles inside it. So one, to prevent gas interference. as the electrons are moving, to prevent the electrons from colliding with the gas particles. Okay, so to prevent the gas particles from colliding with electrons or prevent gas interference. Allows electron beam travel freely. Allows electron beam travel freely. That is another reason. Okay, I guess we gotten a thing. But of course, please be able to contribute the solutions as well. But indicate the question number. Indicate the question number and of course the question that you're answering. Let us go to B9. On the graph of a count rate, so figure B9.1 shows the graph of a count rate in counts per minute against time in minutes. Okay, that is B9. Look at it. So count rate per minute against time in minutes. Define half-life. What is half-life? So is the time taken for half the amount of radioactive substance or sample to decay, or the time taken for half of the sample activity to decay. So however you define this, quite a number of definition. I mean, it's not only this one, but you have other definitions that you can put here. So also as you go through, make sure that you write your own definition. Indicate that you're answering the question on half-life. Use a graph to determine the half-life of radioactive sample. Okay, so to use the graph to determine half-life. So half-life, you're saying the time taken for half of the sample to decay. So original amount of a sample was 12. Half of 12 is 6. So at 6, if we were to follow it here, the time was 2 seconds. I mean, the time was 2 minutes. So half-life is equals to half-life 1 plus half-life 2, then divide 2. We find the average. So half-life 1, we found it to be 2. That is the time here. Then as for 6, let us find half of 6. Half of 6 is 3. So at 3, what was the time? From here up to there, it was also 2 seconds. So 2 minutes plus 2 minutes, then divide 2. This is still going to give us the half-life of what? Of 2. So the half-life is 2 minutes. So half-life for this one is what? 2 minutes. Okay, so that is how we can determine the half-life. So half-life here is equals to half-life 1 plus half-life 2 divide a 2. This is the 2 plus 2 divide 2, which gives us a 2 minutes. Okay. Then give two effects of radioactive substance on the environment. So it causes infertility. So it causes infertility. Okay, so infertility. Then what else? It also contaminates water. So water contamination. What could be the other effect on the environment? So also here be able to suggest. Make sure that you state the question and also put the answers. All right, so that brings us to the end of section B, and now we are going to move to section C. So section C, what was the first question? So look at it. Section C, 20 marks. You are allowed to choose 2 questions. So answer any 2 questions, any from this section. Write your answers in the space provided in this question paper from page 18 to 22. Write your number for the question you have chosen. And I should mention that it is not as usual the way it used to come. This time around, the answer sheet is the same question paper. And that is the reason why we are given the space for writing. So the part for writing we are saying is from page 18 to 22. Now let us look at the question. A car slows down from a velocity of, so let us take note. A car slows down from the velocity. So initial velocity was 40, then it slows down to the velocity of 20. So the final was 20 meter per second, in 5 seconds. So all this happened in 5 seconds as the time. It then moves with this velocity for 3 seconds and then come to rest. So it maintained the velocity of 20 and came to rest in 2 seconds. Plot the graph of velocity against time for the motion of a car on the grid provided on page 18. So let us go to page 18. And I guess you still remember the information. So this is page 18. Okay? This is page 18. So we write the title. What is the title of a graph? So velocity, they are saying plot the graph of velocity time, plot the graph of velocity against time for the motion. So you are going to say graph of velocity against time. Okay, let us plot now. So here, I recommend you leave out this line where it is coming from here. Then you can start from any. This is the velocity time graph. So I can start from here as my 0. Okay. Then now going up, look at that. What am I going to use? I can use, it moved from 1. Here I can use 10. I can move in tens. So I'm going to say 10, 20, 30, 40, 50, 60. I don't know where it started from. Okay, so this is my line for the x-axis. Then this is my y-axis. Okay, so this side is the velocity. And of course, in meter per second, I'm using the scale of 2 centimeter to represent 10 meter per second. Then here, this is the time. Time is what? In seconds. So here I'm going to use 1. So 1. What is the highest time here? 5 seconds. The highest time is 5 seconds. So I'm going to use 1, 2, 3, 4, 5, 6, 7, 8. So time I'll move in ones. 1, 2, 3, 4, 5, 6, 7, 8. That is in seconds. So we are saying it all started from, if we are to go back to the question, look at this. A car slows down from the velocity of 40 meter per second to a velocity of 20. So from 40 meter per second, right here, to the velocity of 20. But in what time? 5. Pay attention to the time. In what time was this? In 5 seconds. So we are going to go at time 5. So this is how you do it. From 40 to 20, when time was what? 5 seconds. So 20 is right here and time is 5 seconds. So it moved all the way from there like this. Okay, this is 20 and maintained this velocity for how long? Maintained this velocity for I guess we are going to produce the graph that is perfect. Maintained, and it maintained this velocity for 3 seconds and came to rest in 2 seconds. Maintained the velocity for 3 seconds. So which means we are going to go from 5 up to time is 8. Okay. So now we have run out of the spaces for time. So we needed to reduce this one. So we are going to go with 2. So 2, 4, 6, 8, 10, 12, 14. So now, where is 5? So 5 is between 6 and 4 and 6. So 1, 2, 3, 4, 5. So 5 is right here. And 20 is right here. So 1, 2, 3, 4, 5. Okay. So we've changed the time. Instead, we are going to use 2 seconds for time. So it will be like this. Maintained this velocity for 3 seconds, which means the next time it will be at 8, like this. Then came to rest in 2 seconds, so it means the final time will be the final rest will be at 10. So the final rest will be at 10. Let me just try to. Okay, so that is how the graph will appear. That is how the graph will appear. So here we've used, that is a scale, 2 centimeter to represent 2 seconds. All right, what are the questions that follow? So this is the graph that we needed. So it started from 40, we draw to 20 in what time? 5 seconds. So it should be coinciding with the time 5 seconds. Maintained the velocity for 3 seconds, which means it was going straight for 3 seconds, which gives us time of 8. Then came to rest, which means stopped moving at the 10 because it took 2 seconds for it to come to rest. So that is the graph. You can even put something like this, it's okay. Something like this. Okay, then what are the follow-up questions? Here, the follow-up questions, we have the retardation in 5 seconds. So calculate the retardation in 5 seconds. So that is question number what? Question number, so plotting the graph, we are done. Question number B1, retardation in 5 seconds. So for retardation in 5 seconds, so I'm going to put this one, B, Roman numeral 1. So retardation is acceleration. So you're going to say acceleration is equals to final minus initial over time. In 5 seconds, the initial was 40, the final was 20. So I'm going to say 20 minus 40 over time in 5. We are going to have what? We are going to have negative 20 divide 5, which is negative 4 meter per second square. Retardation is negative, so that is the answer right there. Then what is the second question? The second question is total distance covered by the car. Okay, total distance covered by the car. This is the Roman numeral 2 for B1. For B2. Total distance by the car is the total distance for the whole shape. Now, under velocity time graph, we use area, or the area under the graph is what gives us the total distance. Now, the shapes that I'm seeing here for me to find the area, I'm seeing the trapezium. This is the trapezium. And also this is the trapezium. The whole of this one, please. So I have 2 trapezium here. And I can find the area of these and add them, that is the distance. So let us find the area for the first trapezium, which is the distance, is equals to 1 over 2a plus b multiplied by height. I'm finding for the big one. Now, this shape that you are seeing, this part, the longest part, is the b. So b is equals to, from down here up to the top there is C, 40. So B is equals to 40. Then my A is this up to here, because these are opposite side, parallel. So my opposite side is A. So what is my A from here up to where it is there? My A is equals to 20. Then my height is this one if it's oriented in this form. So my height is 5. So height is 5. So now let us answer. 1 over 2. What is our A? 20 plus, what is our B? 40. Then what is our height? 5. So if we are to multiply, this will add inside 60. So it will be 60 multiplied by 5 divide 2. This is 30. 30 multiplied by 5. 30 multiplied by 5 is what? You are going to have 150. Okay, 150 meter. So the one for the first one is 150 meter. What about for the second trapezium? What about for the second trapezium? So for a second trapezium, we are going to go for this one, the whole of this one. So this one that you are seeing right here, this on top is our A, and is starting from 5 up to 8. So this is 3. Then the whole of this one is the B, which is starting from 5 to 10. So B is equals to 5. Then from here up to here is the height, which is 20. So we can find the second one. Distance is equals to 1 over 2 A plus B multiply height. What is our A? Our A is 3 plus, what is our B? Our B is 5. What is our height? 20. Then half. That. This is 10. Inside you add, you're going to find 8. 8 multiplied by 10 is 80 meter. So this is what we are going to add now. So total distance is equals to 150 meter plus 80 meter. And this gives us 230 meter, if I'm not mistaken. So confirm this. So that is how you find this distance. Then the end part now, which is I think there's a last question that is for calculations here. Let me see. Total or average speed of a car. Average speed is total distance covered divide the total time taken. So average speed is equals to total distance over total time. Now here, what is the total distance? 230 meter. What is the total time? Total time is 10. So here it's just going to be 23 meter per second. That is the answer, 23 meter per second. Okay, so let us answer now question C2. Table C2.1 shows values of voltage and current recorded by Elena observing a different current passing through a torch as voltage was being observed or was being increased. State Ohm's law. So Ohm's law states that current flowing through a conductor, is directly, proportion to voltage. Direct proportion to voltage. Okay? Provided temperature remains constant. So current flowing through the conductor is direct proportion to voltage provided the temperature remains constant. Right, then they're saying plot a graph of voltage against current using the values given in table C2.1 on the grid provided on page 19. So we are going to go page 19 and see. Now here, we are going to be coming back for the values. Look at this, 2, 3, 4, 6, 8. 1, 2, that is 1, 1.5, 2, 2, 3, 4. Okay, so let us see how we can plot the graph. So here is the graph. What is the title? Graph of voltage. Graph of voltage against what? Against current. Okay, so let us plot it. So we are going to leave out a space here this side. So we are going to put it here, 0, and this will be our x-axis. Then our y-axis is going to be this one. Okay, this will be our y-axis. Okay, so how are we going to move? If you look at the way it is here, you determine the scale. Look at the voltage, the way voltage is. So voltage is moving 2, 3, 4, 6, 8. So how are we going to move? The highest number is 8. So how many boxes do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So here we can move in ones. So 1, 2, 3, 4, 5, 6, 7, 8. So this side is the voltage in volts. So I'm moving in ones. So it means the scale is 2 centimeter equal to 1 volt. Then on the other side, if you look at it the way it is in terms of current is moving as 1.5, 2, 3, 4. So here I can move in the highest is what? What is the highest? The highest is 4. So let me count the boxes that we have. How many boxes are there? 1, 2, 3, 4, 5, 6, 7, 8. So I can move in 0.5. So 0.5, 0.5, which means I have 1.0, 1.5, 2, 2.5, 3, 3.5, 4. So here, in terms of current in amps, the scale is 2 centimeter to represent 0.5 amp. Now, let us graph now. The first point that we are going to graph is 1, 2. Current 1, voltage 2. So 1, 2. 1, 2. So right here. Then the second that we are going to put is 1.5, 3. 1.5, 3. 1.5, 3. So 1.5, 3, it will be here. Then the next one is 2.0, 4. So 2, 0. 2, 4. So where is 2, 4? 2, 4 is right here. Then the next one is, what is the next one? So we have 3, 4, 8. So 3, 4, 8. 3, 4, 8. So 3, 6 right here. Then we have 4, 8. 4, 8. 4, 8 is right there. That is 4, 8. So if we are to join this, it's going to come out that way. So we can even join it from the origin here, from the start here, like this. So this is going to be our graph. Might not be accurate, but yeah, kind of. All right, what are the follow-up questions? So that is the graphing that ends us about 4 marks. Use the graph to determine the resistance of the filament of the torch. So how do we determine, that is question what? Use the graph to determine the filament of the torch. Use the graph to determine the resistance of the filament of the torch. That is C. So question C, I'm going to put it on the graph right here. So to determine the resistance is equals to voltage over current. So I'm going to pick one of the points. So here I can pick this and that. So I've picked voltage as 3, then resistance as 1.5. That is volts, amps. And this is going to give me a 2 ohms. So this is a straight line. So at all point that I pick is going to give me the same. If I want, I can pick this one, which is 4 and 2. 4 divided 2 will still give me 2. Okay? So I've answered the question C. Then let us go to question D. Calculate the energy dissipated by the torch if it operates for 45 minutes when the voltage is 5 and the current is 0.25. Calculate the energy. So what is energy in this case? 45 minutes. So that is the D. Energy is equals to voltage times the that is the power times the time. Now power is voltage times the current times time. So we have 45 seconds. We need to convert 45 minutes. That we need in seconds. 45 minutes, yeah. We convert it into minutes. How do you convert it? By simply multiplying by, so 45 multiply 60. You're going to have 2,700. Okay, I guess I'm not mistaken on that part. So this is 2,700 seconds. So you're going to have voltage. What is the voltage? The voltage in this case that is given is 5 volts, 0.25. 5 volts, 0.25. So voltage is 5, current is 0.25. Okay, let us multiply. So 5 multiplied by 0.25 multiplied by 2,700. How is it going to be? So multiply by 0.25 multiplied by 5. So in this case, we are going to have 33, 75. What are we calculating? Energy, joule of energy. Okay, that is what we are going to have. Then the other question I think should be the last question here. What does it mean in terms of electrical energy when the bulb is rated to 20 watts? What does it mean? This is 1 mark. So this is the question that I leave to you. What does it mean when it is rated 120 watts? So give a feedback on this one. Which means we are going to the last question now here. C3. A wave on a string moves through a distance of 20 meters in 0.1 seconds. Move through the distance of 20 meters. A wave on a string move through the distance of, so this is the wavelength, this is the time taken. Define longitudinal wave. So longitudinal wave is the wave whose vibration of particles are parallel to the direction of movement of wave. So direction of wave. That is what we call longitudinal wave. So longitudinal wave is the one, or is the wave whose vibration of particles are parallel to the direction of the wave. Then they're saying calculate the velocity of a wave. So velocity is equals to frequency times wavelength, or that is wavelength divide period. So what is it happening here? A distance of any, so a wave of string moves through a distance of 20 meters. So that is the wavelength, 20 meters. In 1 second, so this is a period, 0.1 seconds. Calculating the speed, you just divide 20 divide 0.1. What are you going to have? 200 meter per second. That is the speed of a wave. Okay. C, that is question C3, C. Figure C3.1 shows a vibrating string fixed at the end. So vibrating string. So it's a string vibrating. Calculate the period of the wave if the frequency vibrating is 25 Hz and velocity is this. Calculate the what? The period. So speed is equals to frequency times z, or wavelength over period. What are we given here? We are given frequency and we are given the speed, okay, which is v. Then they want us to find the period, calculate the period. So which form of this is going to work? So calculate the period of the wave given that is the frequency and given the okay, so there's no need of even going to go this far because period is just the same as 1 over frequency. So the period in this case is going to be 1 over 25. So what is the answer? 1 divide 25 is equals to 0.04 seconds. So 0.04 seconds. Confirm. That is the what? That is the period. State 2 characteristics of sound wave. What are the characteristics of sound wave? They are longitudinal, or let me say 2 characteristics of sound wave. So I can put amplitude, then pitch. You can put, these are the characteristics of what? Sound wave. So amplitude and pitch. Curtains, that is in the house, using heavy curtains. Then aside from that, using double glazed windows, using double glazed windows. Then we can talk of insulated walls. Okay, so these are some of the ways of minimizing sound pollution, and this specifically in the house. What could be other ways of minimizing sound wave? What does loudness of sound depend on? So this one depends on the amplitude. Okay. So this brings us to the end of this exam. So we've answered the whole paper from the scratch up to the end. Okay, so please, as you go through, mistakes can be made at some point, errors can be made. Make sure that you comment your answers, or you look at where the mistakes would have been made. Otherwise, this is the paper that the 2025 GCE did, and of course we have spent an hour and some minutes to complete this, which is within time. All right, we've come to the end of the presentation. So please, if you've enjoyed the presentation, do not forget to subscribe to this YouTube channel for more revisions. And also, if you're watching this from Facebook, do not forget to like my page. If you're watching this from TikTok, give it a like as well. If you are interested in the online lessons and physical lessons, you can contact the number 0976 402 563. We are found in Kabwata, just near Kabwata Primary. That is our physical location. Online lessons start end of October. So if you want to register for 2026 GCE lessons, you are free to get in touch. Otherwise, we can end here and see you in the next one.